Okay, so now let's see if we can figure out the inverse trigonometric functions for these trig functions. Now remember what the inverse means. That's just the function that untangles another function, right? So if I take the composition of a function and its inverse, I should in fact just get x. So another way of thinking about this visually is I'm just reflecting along the line y equals x. Now, first of all, am I allowed to take inverses? Remember, a function has to be one-to-one or pass the horizontal line test in order for it to be really an invertible function. Let's take a look at sine and look at its graph. And let's ask, is that function invertible? Well, all I've got to ask is, does it pass the horizontal line test? And the answer is absolutely not. In fact, it fails it sort of infinitely often, right? At any of these points, it crosses this, here, 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 here. It goes on forever. So in fact, this is very, very far from being one-to-one. This fails the vertical line test, the horizontal line test, and so therefore, this does not have an inverse. Okay, that's a problem. Well, it's good news if you don't want to deal with inverses, but if you want to deal with inverses, this is a problem. So you know what we do? We just will restrict the allowable domain in order for this thing to have an inverse. You see how great that is? So, first of all, just to warm up to this, let's think about what the inverse would sort of look like just visually. Okay? So let's not worry about any details yet. Let's just sort of play, if you can imagine playing with inverses. These are things that are sort of dangerous. So once again, let me just draw in. This is just a sine function, of course. But now what I want to do is think of what the sort of inverse thing would look like. The inverse thing, remember, is just a reflection over the line y equals x. So now it's like an art thing. Now, how artistic are you? If I were to take a mirror and put it right along here, you would see what that function would look like. Well, you'd see it if it were there. There, you can sort of see part of it. See how it starts to wiggle up? It looks like it's wiggling up the y-axis now. And if you visualize it really, really carefully, deep, deep, almost hypnotic trance, you can see that if I were to take this picture and just physically flip it to there, I'd get the following. This actually takes time to sort of really see it, by the way. Takes a while, but if you look really closely, you'll see that the purple is exactly the flip of this over this line. See how this little part here gets mapped to there, this part here gets mapped to here, and so on and so on. So in fact, you can see this is not a function, this purple thing, because it fails just the good old-fashioned vertical line test. But what if I just restrict the domain? What if I just say, okay, fine, let's just look at the sine function on a little piece, like, for example, this piece. Just up to here, and no more. Just up to there, and forget about everything else. Then, and that's from minus pi over 2 to pi over 2. Then if I take a look at the flip, the inverse, I would get this picture. Just that picture. And that would be the inverse. So that would be y equals the inverse of sine. And the notation we use for this is sine with a little minus 1, superscript. Just like with functions, remember with functions, if you have a function f of x, its inverse is f with an inverse with a minus sign there. We do the same thing here. Now, a little warning, don't get this confused with sine of x to the minus 1. That would equal sine of 1 over x. But if the minus 1 is right after the sine but before the x, that means it's the inverse function. And that's exactly this function here. It's this thing that undoes the sine function. So let me now say this all in words. So what we have is that if I write y equals the inverse function. By the way, another notation which some people use is the arc sine. That's the exact same thing as inverse function. And what that means, so the meaning is that y is the angle whose sine is x. So y is the angle whose sine is x. So that means that sine of y equals x. These statements say the same thing because y is the angle whose sine is x. So sine of y equals x. So these are inverse functions of each other, inverse functions. But this is only defined for x between what and what? Well, between two values. In this case, what we see is it's in between, well, let's see, what's the biggest it could be? Well, it's between, of course, 1 and minus 1. But here, the y can only range from minus pi over 2 to pi over 2. So pi over 2 minus pi over 2. And again, the point is that to make this thing have an inverse, what we do is we only look at a little piece of the sine function, just this piece right here. And we stop right there. We stop right there. You see? And then if you take the flip of that, the inverse would sort of have the same look, but in reverse. So that's the inverse or inverse sine or arc sine function. What about cosine? Well, the same problem occurs with cosine. It's not one-to-one. So to make it one-to-one, we just look at a little piece of it. And for cosine, we look at this piece. See, if I went any further, look what would happen. If I went any further, it would fail the horizontal line test. It would back up onto itself. So I just go from 0 to pi. And what would the inverse look like, or the inverse function? The inverse function, if I flip it, it would look like this. Let's see. It'd sort of be at 1, and it would sort of go out and go like this. So it would look like this. Let me draw it right over here. You have this basic shape. Just the flip of this. This would be y equals the inverse cosine, or another way of saying it is y equals arc cosine. I guess they don't use both c's here. I guess they just write arc cosine. I'm not sure. Anyway, y is, so what this means is y is the angle whose cosine is x. It untangles the cosine function, so it means that cosine of x is the same thing as y. And again, we have this condition. We have this condition that, in fact, you only look at this part of the cosine function from here to here. Because if you looked at any more, it would no longer be a one-to-one function. It would fail the horizontal line test. Okay, so there's the inverse function for cosine. And then finally, what about tangent? Well, for tangent, we pick just a piece that goes from pi over 2 minus pi over 2. And what does the tangent function look like? Well, I'll remind you, the tangent function looks just like this. Notice that just on this region, it is, in fact, a one-to-one function. It passes the horizontal line test. But if I put in any more, it would fail the horizontal line test because I have more stuff here that would click with it. What if I flip that over this line? What would it look like? If you flip, you would see this picture. So you'd have asymptotes now here at pi over 2 and minus pi over 2. Just the flip of this over the line y equals x. This is y equals inverse tan x, or y equals arc tan x. And again, there's this restriction that this is only true for those values that are between minus pi over 2 and pi over 2. There's that restriction. It's very important that you remember it's just in there. Any place else, and it wouldn't be a function. Okay, really confusing stuff, by the way, really confusing, because inverse functions in general are just really hard. So what I'm going to do next is take a look at some numerical examples just to get our feet solid on the ground as to how, in fact, this function untangles the tangent function. So for example, here, what this means, by the way, let me just remind you what this means. Y is the angle whose tangent is x. That means that tangent of y equals x. It just untangles the tangent function. All right, we'll take a look at some numerical examples and get our feet really sort of more solid on the ground from just these visual things up next. I'll see you there.